and GPS. Today, the morning sessions will be mainly focusing on geographical information system. And we have a subject expert here, Madam Ravinder Kaur. She is Professor and Chairperson, Department of Geography, Punjab University. She will be mainly focusing on Introduction to Geographic Information System, which will be very useful to you in the coming sessions also to understand about the practical applications. So, Madam.
Thank you, Madam Jyoti, for this introduction. Good morning, friends. Today we are going to discuss geographic information systems, which is one of the state-of-art technology being used in spatial and other sciences. The word GIS comprises of three letters, G, I, and S. G stands for geography, I for information, and S for systems. The word geography has a connotation in the sense that it relates to different locations. The word information gives you an idea that we are going to work with a database and cull out information out of it. And system speaks of the computer system and peripherals which will be used in this technology. Having said this, I begin the presentation. The presentation has been structured in the following way. We have an introduction, then we try to answer the question, what is GIS? We further move to components. We do types of data. We do tools of GIS, the functional elements of GIS, benefits of GIS, and then try to see GIS as a multidisciplinary science. Yes. What is GIS? As I started with the little meaning of GIS, which means that there are geographical locations and data on geographical locations has to be understood because GIS works in a spatial context. Almost everything happens somewhere, and in most cases, knowing where something happens is critically important. For example, you want to know position of a country boundary, location of hospitals, routing delivery vehicles, management of forest stands, allocation of funds for sea defenses. Now, for all these examples, if you want to lay your hands on a technology, GIS comes very handy to you. Geographical information systems are a special class of information systems that keep track not only of events, activities, and things, but also of where these events, activities, and things happen or exist. Now, the key word over here is where. Where stands for location of a place. And location in geography is very important, and all of you know that no two places on the earth shall ever have the same locations. They may have same altitude, they may have same climate, but no two locations can have the same coordinates in terms of X or Y or in terms of latitudes and longitudes. Geographic location is an important attribute, and it has to be an attribute of activities, policies, strategies, and plans. Geographical problems involve an aspect of location, either in the information used to solve them or in the solutions themselves. And that speaks the utility of GIS as an technology. Now, let us try to understand some of the important characteristics of geographic information system. GIS is a structure which contains spatial information along with its non-spatial information. Whenever we work on GIS, the second letter of this acronym GIS stands for information. Now, this gives you an idea that while working on the information, we are going to work with data sets. We are going to cull out information from the data sets. And these data sets can be spatial data as well as non-spatial data. Spatial data refers to the data which is related to location, connection, distance, direction. And non-spatial information relates to the attribute information on which we are working on. And GIS has a capability to join or to link both spatial as well as non-spatial data. Secondly, GIS is a system used to capture, store, manage, and analyze spatial and non-spatial information. Now, whether if we are talking of capturing, storing, managing, and analyzing, we are hinting on the use of computer system and its peripherals, and this gives an inherent strength to the GIS for which data could be stored, captured, and retrieved at your own will. Thirdly, it's going to be a computerized data management system which is used to retrieve and display spatial information and non-spatial information. Now, these characteristics try to explain in a nutshell what Geographic Information System stands for. A Geographical Information System, which is known as GIS, has the ability to store, retrieve, manipulate, and analyze a range of spatially related data. With a GIS, the user may ask questions of data related to the map, search for patterns and distributions, and also investigate the underlying relationships between different sets of data. GIS handles data quickly and efficiently, proving mapping facilities that may have taken many hours to complete manually. It surely has an edge over the conventional mapping technology where maps were produced with hands. GIS is a computerized data management system used to capture, store, manage, retrieve, analyze, and display spatial information along with its attribute information. Now, this summarizes what GIS stands for. The keywords need to be noted here: capturing, storing, managing, retrieving, analyzing, and displaying what? Spatial information. Along with what? Attribute information. And this is what GIS means. So you have an information system, you can just see, and then we have geographic positions. When we are going to amalgamate the two, we are going to talk of this technology. This is a geographical information system which provides the capability of integrating information system with the spatial data or geographic position to solve the real world queries and problems. Now, coming to the components of GIS. A GIS can be divided into 6 components: people, procedures or methods, hardware, software, data, and network. People are the viewers, they are the general users, and they are the GIS specialists who want to use GIS technology. When we talk of procedures, these means there are steps taken to answer the question which may be based on spatial data or attribute data and which need to be resolved. It contains of a hardware where you have your computer system and various other peripherals. As software, we have different GIS software packages like ArcView, ArcGIS, QGIS, etc. As far as data is concerned, we can work on data statistics, crucial to check up the quality of the data before obtaining it. And I would like to emphasize, when we are working on the data, it is the both sets of data, that is spatial data as well as attribute data, which is going to be used when we are working on data sets in the GIS environment. Next is networking. That means we combine all the above to make it a system, and it runs in a system approach. Now, this is how you can see what are the components GIS. You have people, you have hardware, you have procedures, you have data, you have software, and this in network is called GIS. And this is how GIS works. Now, GIS has subsystems. In itself, it's a huge system containing few broad subsystems. Number one, data input subsystem, which means we need to have pre-processing and transformations before we try to work in GIS information system. Then we have data storage and retrieval subsystem. This means organizing for retrieval, editing, and updating. We have data manipulation and analysis subsystem, which means we go for aggregation, disaggregation, and modeling with different data sets and data structures. Last is reporting, that is the output subsystem, which means that whatever desired output, we can have it in GIS technology. It could be tabular, it could be graphic, or it could be a map. Now, types of GIS. There are a number of GIS information systems available today. They range from high-powered analytical software to visual web applications, and each of those are used for a different purpose. Due to the vast number of GIS available softwares, it is simply not possible to provide training for each individual software here. However, there are common features in all the GIS softwares, and we can understand these basic features, which will give you confidence with any GIS system that you use in the future. There are three types of GIS systems available. We have web-based GIS, that means online navigation system. We have GeoBrowser, the Google Earth, and we have desktop GIS. For example, ArcGIS. Most of us working in universities and different training institutes work on desktop GIS. Now, what are the types of data which has to be used in GIS? And we need to understand what does it mean. Geographical information is different from other kinds of information and therefore requires special methods to be analyzed. Here are some characteristics that make geographical information special. First, it's a multidimensional concept. At least two coordinates must be specified to define a location. And when I say two coordinates, it means X coordinate and Y coordinate, or latitude and longitude. Voluminous. It's a geographic database that can easily reach a terabyte in size. Different representations. This is how which is done and strongly influence the ease of analysis and the end of results. It requires projection to flat surface. Whenever you want to transfer the grid or the graticule of latitudes and longitudes on a flat surface, you require projection techniques. And one must know the projection techniques, which are very crucial to the understanding of the transferring the grid or graticule on a flat surface. It requires unique analysis methods. There are several analysis methods of GIS which are very useful, and we have overlay, we have buffering, we have querying, to name a few. Analysis requires data integration, and there lies the beauty of any GIS software, where spatial as well as attribute data can be integrated to the best use of querying, buffering, or overlaying. Data updates are expensive and time consuming, and GIS gives you an opportunity to do away with what is redundant and to add what is new. So map displays requires fast data retrieval, and you have the output in the form of map, and this is what geographical information system promises its users. Now coming to a detail of types of data. When we are talking of data, we have two major categories of spatial data and non-spatial data. And then we have data structures or data models in which these data could be stored. For example, the spatial data, we have two data models. We have vector and we have raster. When you try to make a map with the vector data, you have to use the polygons, the lines, and the points. Remember, all the data in the real world, if it has to be represented on a map, it has to use the symbology of point, line, and polygon. And this is how we represent the real world on a map. While representing the real world on a map, it is abstraction of the real world, and the abstraction of the real world calls in for selection of symbols or appropriate symbols for the things to be shown on the map. And normally there are three kinds of symbols: point, line, and polygon. And when you are trying to represent the real world on a map with these three kinds of spatial entities, you are using vector data model. Coming to raster. Raster data model is a representation where you have data as pixels or picture elements. It could be continuous, it could be discrete. When you talk of non-spatial data, we have network, we have hierarchical, and we have relational. Now these data models are for managing non-spatial data on which we work in GIS environment. Now coming to spatial data and its types. Spatial data is also known as geospatial data. Location, size, shape of any object on planet Earth, such as building, lake, mountain, or township. We have two forms of spatial data, or two data models of spatial data, which are vector and the raster. In the first figure, you can see the raster representation of the spatial data in form of pixels. Similarly, in the figure 2, we can see the vector representation of the same data as polygons of different colors. If we take one as a forest area, look at the representation and the difference. How does it look in raster and how does it look in vector? Similarly, if 2 could be taken for grasslands and 3 could be taken for a forest area or some guest house, 1 could be for water body or any other spatial environs around you, this could be a difference in the representation, where in one form you have picture elements or pixels, in the others you have a representation by point, line, and polygon. Now, vector in GIS is a format which stores information about any feature of the Earth in 3 different types or objects. Polygon, these also are called as regions. Lines, they are called arcs, and point is for a place or a particular location. Vector structures start and they end at points of a line, and these are called nodes. Any change of direction on a line is a vertex. Lines are joined by sharing a common node, and polygons are joined adjacently if they share a common line. This is how we start digitizing a map which is in the vector structure. Digitizing means when you try to draw the map on the screen using a digitizer or your mouse, That is how you input the spatial data in your GIS environment. Vector objects are all created from the general graphic representations of single X and Y coordinates. Points are single coordinates. Lines are strings of coordinates, and polygons are a closed string of coordinates, and they often compose multiple lines. Now, this is a diagrammatic representation of vector data, where vector means each object is composed by a series of XY coordinates. Points are single XY pair, as you can see in the first diagram. Lines are nodes at beginning and end, vertices for changes in direction along a line, and then polygons are closed set of lines. So the first representation is by point, the second representation is by line, and the third is by polygon. You can use points for discrete locations, you can use lines for linear features, and you can use polygons for regions or closed administrative units. Now coming to spatial data, that is raster. Raster is a set of rows and columns that forms individual cells. Each cell has a unique data value and clearly has an area coverage, which is proportional to the cell size. Raster cell is also called as pixel. Raster data is also known as grid data, and it represents the fourth type of features, surfaces, that means volume. Raster data is a cell-based, and this data category also includes aerial and satellite imagery. This is a raster representation of a map which shows orange as built environment, blue as water, green as forests, and the darker green as wetlands. If it is a raster representation of a map showing these four different kind of spatial data, the representation is going to be something which has been shown on the screen with different colors, and it is in form of pixels. So spatial data can be represented as raster or as vector, as discussed earlier. Now, we have different types of raster data. We have continuous and we have discrete. An example of discrete raster data is population density. Continuous data examples are temperature and elevation measurements. These are some of the representations of the raster where I show you the district map. This is an example of discrete raster data where you have different categories for the distribution of population density. Population density refers to the number of people living in per square kilometer. Now, over here is a map showing different density patterns. And density data, as I've already told you, is a discrete raster data. Similarly, we have continuous data. For example, the elevation, where you try to show the contours, or we have districts draped over elevation. So this is a continuous data where you see a continuous increase or decrease in the values, whereas when you see densities, you don't find a continuity in the data. So we can show both discrete as well as continuous data in raster. Two types of raster data sets, thematic data and spectral data. Thematic data is based on one theme or multiple themes, or for which is representing one or more themes. Digital elevation model, that is DEM, is the best example for this. This is a DEM generated out of the contour elevations, and then when you can label it in terms of various class intervals or various categories. Now coming to raster data and coming to spectral data, especially, it includes data which is captured in different wavelengths. One wavelength is suitable for few types of features. producing one data layer. Other wavelength is suitable for other types of features, producing next data layer, and so on. And I'm very sure the lectures on remote sensing must have captured these capabilities. And over here, you can use it for understanding what spectral data looks like in a raster format. And when various data layers of different wavelengths are combined to form one scene, imagery is formed. And I am taking this example to show you because imagery has a raster representation of the spatial data. Now, this is an satellite imagery which shows you the coverage of an area. And when you take up these different layers, these could be layers of different features. One could be for water, one could be for forest, and so on and so forth. But yes, the representation is surely in form of raster. Now, this is the difference between vector and raster. Now, when you are trying to locate a spatial entity, for example, the location of a hotel, it has to be shown as point on the map. In the raster data, it will be shown as pixels, whereas in the vector data, you will have points showing location of the hotels. Similarly, if you have a linear data and you have lines representing a linear data, for example, they could be sky lifts. The vector representation would be in the form of lines, and these are the different nodes, and these are the arcs connecting different nodes, and this is what I was explaining earlier to you. And this is the raster representation of the linear data. Similarly, if you have a polygon of forests or an area of forests, this is what it looks like in vector when you have closed polygon with different nodes and arcs. But when it is represented in the raster format, it looks like this representation. The network of roads, how does it look on the map? It looks on the map something like this. When you talk about the vector representation of a network of roads, but in the raster, it looks like this. Similarly, if it's a surface elevation, on the vector representation, it may look like the joining of contours and its various, you see, points of the equal height, whereas in raster, you will have a different kind of representation of the surface elevation. So this is the difference between vector and raster representation of spatial data of all the spatial entities, point, line, polygon, and network of roads. Now coming to non-spatial data, any attributional information related to either feature like building, construction material, building's height, building's occupancy, which can easily be recorded in tabular format and is attached to the feature when it is opened in a GIS environment, is non-spatial data. It can be called attribute data as well because it generally defines additional information about each spatial feature housed in a tabular format. Now, this is a map which shows different spatial entities. But when you attach the non-spatial data or the attribute data for these, it could be the area, perimeter, and these area and perimeter can be taken as an example of the two attributes which we can see for any spatial entity. These attributes can be any data and it is represented as alphanumeric. And not only this, you can have n number of attributes for spatial data, and that is the beauty of a GIS software when it tries to link the spatial data and the non-spatial data through a GIS software and help you to derive the maps as an outcome. So you have Suppose this is a point on the map. Now this is its ID, and these are the attributes of this ID, where it shows it has an area and a perimeter of this magnitude. Similarly, you can go for any point and you will have a subsequent set of attribute information, and this can be linked in GIS software and maps can be produced. Now there are tools for GIS and we need to have a look at them. As far as information is concerned, where do you get your data sets from? You get your data sets from both the sources. The acquisition of data would require exploring the data sets for spatial data as well as attribute data, remote sensing data, geographic data from various Survey of India maps or various town and country planning maps or maps prepared by any other agencies. Your aerial photographs, aerial surveys could be a source of spatial data. Then you could go for non-spatial data, and depending upon the objective of analysis and depending upon what you require, you can go for the attribute data. You have n number of agencies which give you attribute data. If somebody has to work on population data, the census has to be explored, which gives you data on all the population attributes. If you have to work on agricultural data, you have statistical abstract, where you get all the information pertaining to agriculture. Similarly, if you want to work on meteorology, you can go for meteorological reports, so on and so forth. In hardware, we have already seen that you require a computer, digitizer, scanner, and printer and plotter. I'll come to it in a few minutes. When you talk about software, we have already seen it could be a desktop GIS, internet GIS, or any CAD software or database softwares. We can have multimedias also, when you can integrate photographs, videos, and 3D models. 80% of the government data collected is associated with some location in space, and that makes the data geographic. Attributes or the characteristics which can be used to symbolize and provide further insight into a given location help you to derive information out of the data sets which are non-spatial in nature. It's a seamless operation linking the spatial data with the non-spatial data and the information to the geography, which requires hardware, networks, software, data, and operational procedures. And not just software, not just making maps. GIS is something beyond. We have some functional elements of GIS, and one needs to understand how do we move about when we are trying to work in a GIS environment. The first step is data acquisition. You have to acquire data, both the spatial as well as the attribute data, before you go to work in a GIS environment. You have to digitize the data. Digitize the data means that you have to feed the data into the computer system. When it comes to attribute data, it could be simply typing the data in a tabular format, which could be in an Excel sheet, or it could be the space given in the software itself. The Excel sheets can also be joined within the software. There is a provision for it. Whereas when you try to feed the coordinates of the spatial data, the process is known as digitizing, and we can do the digitizing because every GIS software provides you with a module of digitizing where you can use your mouse for digitizing. Similarly, when you have digitized the data, there are possibilities that you are going to commit some mistakes, whether digitizing spatial data or attribute data. So detection of errors and correction of errors is required, and this is known as data editing. Then the GIS software needs to tell what mathematical properties, or what is the relationship between different types of data which you have digitized. And this is known as topology building. You need to go for a projection transformation because the grid or the graticule which is on the globe has been transferred on a flat surface, and you require map projections or techniques of map projections to go in for the desired map projections, and that shall be decided as to what area of the earth are you working and what is which you want to show. Similarly, you go for pre-processing from analog to digital, and you try to convert the units. Then we talk about data management, and you have data archival, you have databases of which we have recently talked, and that data model or data models, whether they are related to spatial, that means whether they are raster or vector, or they are data models for aspatial or attribute data, whether it is hierarchical, networking, or relational database. We are trying to manage the database, and this in called database management system. Then we have various techniques where we can go for analysis, we can go for buffering, we can go for overlaying, and we can also go for connectivity operations. We can go for analyzing as to which nodes are connected and what are the patterns they are forming when you're trying to see the connectivity of some linear data, for example, road network or telephone lines, or it could be railway network also. We can have output in form of thematic maps. We can even have 3D bird's eye view, and we can have maps prepared as per the scale. Once GIS is implemented, we have a lot of benefits which can be accrued from GIS. This explains the rationale of using GIS as a technology. Why use GIS can be best understood if we are able to count the benefits of GIS. GIS gives you an opportunity for better maintained data. Delete what is not required. Add what is new. So you have deletion and addition, and this can be done simply in rows and columns where you have attribute data and you can update your data. You can have a standard format to work, and this helps you in data sharing. You can go for an easy revision. Yes, remove the redundancy and add what is new, and you can go for an easy revision whenever you want. Easy updation, easy units conversion, easy to share, easier to search, analyze, and represent. Many value-added products can be obtained from GIS because it has a tremendous capacity of going in for various data analysis techniques, whether you go for buffering, whether you go for overlaying, or even when you go for querying. You enhance the productivity of the staff. Time and money is saved. And yes, better decision making can be obtained. And these days, GIS is viewed as decision support system. This means that with this technology, when you try to take decisions which are based on spatial data and which are based for the betterment of people, you can easily reduce the element of subjectivity and you can go in for an objective analysis. And this objective analysis could be a basis for your policy formulations and policy implementations. And that is why it gives you a greater power in decision making, and realtors, government agencies are using this because it has immense utility. And most of the decisions when the governments have to take are related to the spatial data, whether it is to locate a new school in a village or to locate a new hospital in a village. one can go in for a precise, objective, site suitable analysis before one declares the site as the chosen site for taking up of any project. Now, I told you in the beginning that GIS is a multidisciplinary science. All the sciences which use spatial data are the users of GIS. Geography, statistics, cartography, remote sensing, photogrammetry, computer science, operation research, mathematics, surveying, civil engineering, geodesy, environmental planning, urban planning, whatsoever stream of science uses spatial data can use GIS safely as a technology for taking decisions. We have so many GIS softwares, as I told you earlier. ISRI is the main company. You have ArcInfo, ArcView, ArcGIS. Then you have GRASS. You have a Idrisi software, which was manufactured by Clark University, and it's a good software to work on the beginners, and you can lay out your hands on that. ILVIS is another integrated land and water information system. It's a very simple software to begin with for the beginners, and then you can go in for later versions. But I think in the practical sessions to follow today, you will be given some hands-on training on these working of softwares, and that shall enable you to explore what are the utilities of GIS. As far as the advantages and disadvantages of GIS are concerned, one has to explore these two. The advantages lie in the fact that you have to explore both geographical and thematic components of data in a holistic way. Yes, this is a technology which enables you to link the spatial data with the attribute data. That means the geographical data and the thematic components. And you can arrive at a holistic analysis, and this holistic analysis could be a base for your policy prescriptions for any area or for any segment of population. It stresses geographical aspects of a research question. Whenever you have to use this technology in research, one poses a question regarding the location, and one understands how locations become important, whether you are working on them or whether you are trying to take a decision about locating certain facilities, amenities in a village or in a city, and that points out how locations are important for any analysis to be taken up. It allows handling and exploration of large volumes of data. Nobody stops you for the analysis where voluminous data can be handled with great ease. Redundant, throw it out, add whatever is new. It allows integration of data from widely disparate sources. You can use different disparate sources, and it has a beauty that it can integrate the data even if you acquire from different sources on different data sets. It allows analysis of data to explicitly incorporate location. I am trying and again hammering on this point that the location element is very, very important, and it has been missing a lot in our policy decisions. Now, if the locational element is included in the decision making, the policies framed are going to have far-reaching and good effects which they missed out earlier. It allows a wide variety of forms of visualization. Yes, you can go for visualization, especially the 3D visualizations, which you call DEM or digital elevation models, and it gives you an idea how would the things look in a visual environment. GIS has some limitations. The data are expensive and so are the softwares, so you require a cost. But once you incur a cost, it surely gives you returns. You have to learn how to use a GIS software. It requires a training, and there's a learning curve. And the more you practice, the more you try to get yourself familiarized with the software, the learning curve keeps on rising high. It shows spatial relationships, but does not provide absolute solutions. Here, you have to depend on the human mind, because it's the human mind that has to interpret the results. The technology can only analyze things and gives it to you. And it's the human mind which has to see the entire perspective of the solutions, and it has to see the entire things in a holistic manner before you take a decision. But it surely helps you take a decision which are much more objective and locational based. The origins in the earth sciences and computer sciences has given a spurt in use of this GIS, but solutions may not be appropriate for humanities research, because in humanities research you deal with individuals, and unless and until you understand the requirement of individuals and you treat people as people, you cannot come to a conclusion. So there is a catch in the technology. Whenever a technology has to be used, it's the man to master it, not the technology. It can be used as an analyzing, but when it goes to interpretation, the human minds, the experts have to interpret the results before they recommend any solution or any strategy. Thank you.